Thank you for taking some time out to join myself and Lloyd Roden for today's iSQI Expert webinar. The title of the webinar today is The Top 10 Myths and Illusions in Software Testing. So I'll introduce myself first. My name is Debbie Archer. I'm Managing Director for iSQI Limited. iSQI is a group of companies, and I'll explain a little bit in a moment about that, but won't take up too much of your time. And as mentioned, I'm delighted to have with me Mr. Lloyd Roden, who's a software testing trainer and consultant from Lloyd Roden Consultancy. A little bit about the format of today. You'll notice that on the right-hand side of your screen, you can actually pose questions. Please pop them in there, and at the end of the session today I will ask Lloyd if he can actually cover those questions for us. So pop them in there, and Lloyd's got a lot of experience and expertise, so anything you think of, let us know and we'll see if he can answer it. If not, we'll get back to you after the seminar. A little bit about iSQI, the International Software Quality Institute. Global organisation, and we're actually headquartered in Potsdam in Germany. That's where we have our International Service Centre, very talented team based there. We have myself based in the UK with iSQI Limited. We have our BV in the Netherlands and our Inc. in Boston in America. We have a significant network of invigilators around the world, and we offer exams in multiple languages and we cover multiple schemes. We are a global exam provider for iSTQB. We offer the full portfolio of iSTQB exams with one gambling pending in a number of languages. As well as iSTQB certifications, we offer A4Q, Selenium Design Thinking and Artificial Intelligence Software Testing certification, which are proving very popular at the moment. And we also have an extensive Agile portfolio. And we've on that slide a few of the organisations who we are also the qualification board for, including the XQB for usability and user experience, IREB for requirements engineering, and the TMMI Foundation. I'm going to quickly mention exam delivery because it's a question we often get when we are doing these sessions. So exams with iSQI can be taken in a number of ways. You can attend one of the 5,200 Pearson VUE test centres around the world. Now, obviously, we are in a situation at the moment where COVID is perhaps making access to the test centres a little bit difficult. So I'm very pleased to say that we are offering most of our portfolio, including all iSTQB exams via Flex, which is our remote proctor exam solution. And I've popped there the link, so you'll be able to find the full portfolio. If you have training, when we get back to normal, you can take the exam as a paper exam after the training course, or maybe at your organisation's location, or you can take it as an electronic exam after training also. We call that SMEX. So just wanted to cover that because, as I say, I know it's a question that we're often asked. I'm not going to say too much more about iSQI. I want to get into the presentation with Lloyd now. So I'm going to hand over to him to introduce himself, and I know this is going to be absolutely fantastic content. So Lloyd, I'm passing over to you now.
Oh, good. Right. Okay. Welcome, everyone. Thanks very much, Debbie. Welcome to this, my very, very first webinar. I've resisted for a number of years to do this type of thing because I'm a very old-fashioned guy and I like to see people's faces and interact. But so this is my inaugural webinar. So welcome to this, and thank you very much for taking time out to be here. Before I begin, firstly, thanks to iSQI for organising this, and to Debbie and Alex, and also to hope that everyone listening is well and healthy and staying safe in these unprecedented times and strange times we're in. Just a little bit of background to me before I start the presentation, just so you know who I am and where I'm coming from. I've been in the software industry now for getting on for 40 years. When I wrote that down, it made me feel really old. I started out as a developer, and I was a developer for 5 years for an insurance company, and I'll be saying a little bit more about that a bit later on in the presentation. out of the development, I then moved into testing, and I've been in testing now for over 30 years, probably about 32 years in software testing. And I've been doing what I'm doing now, as in training and consultancy, for the last just over 20 years. So this is my Dispelling Testing's Top 10 Myths and Illusions. I hope this is going to be informative. I hope it's going to be challenging, but also I'd like a little bit of fun as well. So I've got a video clip at the end, which I hope is going to work, just on an illusion that you might like. So hopefully we'll have time for that. So before we get into my top 10 myths and illusions, I just want to set the scene. I want to talk about what myths are and what illusions are, because then that paves the way of a foundation for my top 10 myths and illusions in software testing today. So here's a definition of a myth. It's a popular belief or story, fiction or half-truth, that has become associated with a person, institution, or occurrence, especially one considered to illustrate a cultural ideal. It's a made-up story that can seem believable. So I've got some myths here, which you may or may not have heard during your time span. So eating lots of carrots helps you see in the dark. That's something my mother always told me, to make me eat my carrots. Now, that is actually a half-truth, because eating lots of carrots doesn't give you infrared vision, but what carrots have is vitamin A. And vitamin A, we know that it helps the pupils dilate in your eyes. So this was something that was brought in the World Wars to encourage the soldiers to eat carrots so their pupils dilated quicker. Eating crusts of bread makes your hair curl. That's absolutely false. That is not even a half-truth. So those out there with curly hair, it isn't because you've eaten your crust of bread. Eating fish gives you brains. That's a half-truth, because fish contains omega-3 fish oil, and omega-3 fish oil actually helps the brain cells improve. So having fish actually helps the brain sort of improve itself and help the cells in the brain. You must drink 2 liters of water a day. That was, I think, something put out by Perrier back in the 80s. That's actually false. In fact, they did an experiment with children, and one group of children they gave just pure water, the other group of children they gave orange juice, and there was no difference at all. And they had this experiment for over about 3 or 4 months. Eating chocolate causes acne. That's absolutely false. So you can eat as much chocolate as you want. Another one that my mother always used to tell me, watching too much TV gives you square eyes. And that's absolutely a lie. And going through these, I just realized how much my mother used to lie to me, actually. Stepping on a rusty nail causes tetanus. Now, that's a half-truth, because tetanus is an anaerobic bacteria which is caused by an open wound. So any open wound can give you tetanus, and that's where we have tetanus jabs to protect ourselves. So a rusty nail could cause tetanus, but other things could as well. Feed a cold, starve a fever. Ever heard that one? My mother always used to say that. So if I had a cold, I was force-fed, and if I had a fever, I was starved to death. So basically, this is a half-truth. The reason being is that when we have a fever, our temperature rises. And so what they used to think in the old days was that by giving you food, that actually increased the temperature, your temperature. So with a fever, you needed the temperature to come down. And so that was the reason they said you shouldn't eat food, because your temperature should come down. But actually, raising the temperature was a natural biology in our bodies to actually cope with the fever. And if anyone's out in the States, injecting disinfectant will cure the coronavirus. That isn't even a half-truth. That is absolutely false. So please don't do that. Now, if we have an illusion is an erroneous perception of reality, a misleading image presented as a visual stimulus, something which we see that's not there or want to believe is there. So there's an illusion. That person is not actually holding the sun, but it's a photographic illusion of them holding the sun. Here's another one where the trees have actually, that photo has been taken that actually makes a face, and that's another illusion. So let's get into my top 10 myths and illusions. And some of these you might agree with, some of these you may not agree with, and that's okay as long as it's not violent. I'm happy with that. So here's my first one. One of the things that I've come across with testing is the ability to estimate how long testing is going to take. So the concept here is that test estimation is very difficult. Well, actually, sorry, but that's false. Actually, test estimation is very easy. Anybody can do it. In fact, I could come into your organization, any organization, and I can estimate your testing effort for you. I might not be right, but I could estimate. Now, the problem we have here is managers. Our managers do not want an estimate. You see, an estimate is an approximate calculation or judgment based on professional understanding of an expert. There's a key word in that definition. It's an approximate calculation. So when they ask for an estimate, they don't actually want an estimate, they want a quote. Now, a quote is a proposed cost submitted by a contractor to a prospective client. It's fixed price. So just recently, we're going to have a new door fitted, our front door, and I didn't want them to give me an estimate. I wanted them to give me a quote. I wanted to know the bottom line figure as to how much it was going to cost. So quoting for testing is very difficult. Why? Because we are dependent. We're not an island, we're not an isolation. We are dependent on the quality of the requirements. So, you know, if somebody says in a requirements the system must be fast, that's very ambiguous. The system must be user-friendly, the system must be reliable. We're also dependent on the quality of the software, and I'm going to come back to that as my second myth. And also the quantity of the software, how much of the software we're getting. So we are dependent on those aspects. And so therefore, that will influence the effort that we need for testing. The other thing is, testing never finishes, it just stops. You see, we can go on and on and on testing, which is not the same as with developing software. With developing software as a developer, we actually know we've got a product, we've got an application once we've got it. So therefore, it's there. But testing, we could do negative tests, we can do positive tests, we can do usability tests, do security tests. We can go on and on and on testing software. And that's one of the problems management have with software testing. And also, have we ever asked our customers what level of quality is required? Now, if we ask that question, they're bound to say perfection, but perfection comes with a price. The other major aspect, and I'm sorry if there's any high-level management out there, but they're very unclear as to what goes on in testing. So I've got an image here, which I hope is going to show you what I mean. Let's imagine that we've estimated 4 weeks of testing for a particular project. Now, what are we doing in those 4 weeks? For our managers, they believe we are testing, okay? It's 4 weeks of testing. Now, managers don't like 4 weeks of testing. It doesn't fit with their schedules, so they cut us in half. Now, they give us 2 weeks testing. So what are we doing in those 2 weeks? We're testing, okay? I know it's less testing, but we're still just testing. Now, let's imagine our managers have a dream on the Sunday evening, and they believe this is a dream about this project, and it's the best project ever. And they have given us 2 weeks, but we didn't take it. We didn't need it because the software quality is very good. So we only needed 1 week. So what are we doing in 1 week? We're testing. And to management, it's the same, whether they give us 4 weeks, whether they give us 1 week. And let me say, if I play devil's advocate, if the management give me 4 weeks testing, I'm going to find more defects. I'm going to find more bugs. That's going to slow the project down. If I only give you 1 week, you're going to find less bugs, and that's going to speed things up. So, okay, there's an illusion. Count the black dots. Okay, you're going to get very squiffy eyes once you finish this presentation. Okay, now Another myth, it's a half-truth. You see, I said test estimation here, I should actually say test quoting, but test estimation involves effort and resource. So here's the fact. The schedule is made up of effort and people. So if I've got 500 days on a project and I've got one person on that project, that will give me 500 elapsed days. But if I have 500 days on a project and I've got 5 people on that project, then basically that will be, what's that, 10? 500 with 5 people, that's going to be 100 days elapsed time. Now, this is a half-truth for testing because we need to put in there quality. Effort plus people and quality equals our schedule. There's a direct correlation between the quality we expect and have of a piece of software with the effort that we are actually having. So that direct correlation here. And by the way, there's a great book on estimation by Frederick Brooke. And basically in his book, he said 9 women cannot have a baby in 1 month. It's a physical impossibility. And he then goes on to say, and this is for any project, there are some activities that you cannot accelerate just by adding more resource. Okay, it just doesn't work. So we need to estimate and monitor and report on the quality and the costs. So how do we estimate this quality? Well, guess. I think we're going to find 50 defects. We could use historical data, previous projects. We could use statistical measures like defect density. Or if you're in Agile, why don't we use story points? So if this user story is worth 1 story point, then we could actually have 1 defect that we're going to find. If it's a story point of 13, then we're going to find 13 defects in there. There could be a correlation there. So let's go back to our 4 weeks of testing. Okay, this is what we've estimated. And in those 4 weeks, we are going to provide the project the platinum service. But we've already said that we want to estimate the quality. So in doing that, we have said we are going to find 80 bugs in that platinum service over that 4-week period. But the management don't like the 4 weeks. And we've already said by not understanding what we're doing in testing, they cut us in half. So basically they give us 2 weeks, there it goes. So what we now do is we say, that's fine, you're going to get the silver service. And the silver service, we are only going to find 40 bugs. Now they've had that dream and it only takes one week. So they come back and they say, we've just got 1 week. So that's okay. We have 1 week. So now we offer the bronze service and we're going to find 20 bugs. So the upshot of this is, the fact that we've got 1 week, we're providing the bronze service, we're only going to find 20 bugs. And by the way, if your manager turns around and says to you, so what is in the bronze service? You can just say, not a lot really. So we've got 20 bugs, but here's the thing, what about those 60 bugs that we were going to find, but now we don't find them because we don't have the time? Where do they go? They go to our customers. So recognize we can test in less, okay? We can. If you give me a day, I can test. If you give me a week, I can test. But the quality that we are going to deliver has to be greater if you give us more time testing. That's an image there of a fence. Just to give you a little bit of background, 20 years ago, my family and I moved to this house we're in, and on Christmas Eve, we just moved in the September, and on Christmas Eve, our fence blew down. We couldn't do anything about it until the January, and I remember calling a fence person out to measure up and give us a quote, and the fences that he put up was very good. And I remember him giving us the quote. He was standing in my garden. He said, Mr. Roden, he said, it's going to cost you £1,000. Now, this is going back 20 years ago. You could have, I nearly fell off my chair. And I said to him, that's extortionate. I said, £1,000. I said, surely you can do it much less. And he did an interesting thing. He actually got out pen and paper and he wrote down the name and the telephone number of a person that could do it for less. And he said, Mr. Roden, he said, this person could do it in a fraction of the cost. He said, but let me tell you this, my fence will still be standing in 20 years. I'm not sure about that other guy's fence. And I went with him, and I'm looking out of the fence now, still standing. So we can test in less. However, the quality will be reduced. So ways that we can monitor actual versus expected defects, trend analysis, forecasting. If that first graph there is showing the prediction, we're thinking we're going to find 30 defects, and in the first 3 days we've found 22 defects. Things are not looking good, so therefore we can predict what is likely to happen. So it's not just the having that number, but it's actually also saying what the trend is. Okay, so cost of releasing early. So is the ball closer to the top or the bottom? Well, actually it is bang in the middle. Number 3, testing should make the release decision. Absolutely false. You see, when we have this inevitable cost, time, quality triangle, and the scope is in the middle, testing is very much focused on quality. We've got very much a bias towards the quality, but we need to realize that there are other factors in our systems that will influence the release decision. It could be marketing, it could be contractual. So we don't make those decisions, but what we do is we provide the stakeholders with information that's timely, relevant, accurate, and predictive, so that they can make their informed decisions about the quality. So here's something I'd like you to take away from certainly this myth. If you're asked ever, can we go live today? The answer is always yes. Yes, however. Yes, however, we've only supplied the bronze service. Are you happy with that? And there's 60 defects that are likely to be going out to the customers. Yes, however, we've still got 30 high severity defects in the system. Do you want to go live with those 30 outstanding severity defects? Yes, however, our prediction of the quality was much higher than it actually is, and the quality is much poorer, so you can go live if you want. So it's our responsibility as testing to offer our opinions about the quality of the software, and they may not be agreed with. You know, there's many a time in projects in the past that I said to my manager, I really don't think we should go live, and they've said to me, I hear what you're saying, Lloyd, however, we are going live. And that happened with Steve Jobs with the first launch of the iPhone. They had a serious bug at the release date, and I'm sure the quality manager would be saying to Steve Jobs, Steve, we shouldn't be going live with this. And Steve said, we're going live whether you like it or not. And as they say, the rest is history with the iPhone. I'm a big fan of Disney. With my grandkids and my kids, we watch Disney films. But I always remember in Pinocchio, Jiminy Cricket was the conscience of Pinocchio, telling right from wrong. And I think testing is the quality conscience of the project. And we may not be liked, we might not, our views might not be taken on board, but we are the conscience of the project. And the highlight warning signs very clearly. I was talking to an airline pilot once about in the dashboards, and he said a very, very interesting thing to me. He said, Lloyd, he said, when a light comes on, a red light comes on, he says, we can easily not see it. But if the light is flashing, it draws our attention. So he said, in the cockpit of an aircraft, he said the flashing lights are more serious than just the light coming on. So I'm not a fan of quotes, but this one is incredible. It says, the bitterness of poor quality is remembered long after the sweetness of meeting the schedule is forgotten. And if you don't believe me on that, then just have a Google at the 737 MAX, Boeing's aircraft that's still grounded because of a software bug. This is an amazing illusion. What I'd like you to do is just have a look at the dots of that lady on the left, okay? The dot on her nose, just for about 10 seconds, okay? So I'm just gonna time you for about 10 seconds, and then I'll say, move over to the right-hand side, okay? So you've got another 5 seconds, keep focusing on the dot. Now move over. Isn't that incredible? Okay, number 4, large numbers are better than small numbers, okay? So here's a series of large numbers. We got a billion, we got a trillion, we got a quadrillion, we got a quintillion. Here's another large number, 1.79 trillion pounds. Now, we don't know what that means. It's meaningless without the context. But if I put the context in there, suddenly it makes a little bit more sense. This is the UK debt that the Office for National Statistics gave us in February 2020. Now, I believe that is hugely more now with the COVID-19 issue. So our bosses ask for all this information, and I'm just wondering if the information that we're supplying is absolutely necessary. Okay, the managers need information for doing certain things, but I'm often unsure about the purpose of what they're wanting. They're often wanting large numbers because large numbers seem a lot better than small numbers. Let me give you a for instance, okay? Here I've got a quote here. People that are not used to quality always chase quantity. So, this information in testing, how many tests have you run today? Okay, the larger the number, the better. So I've run 10 tests today. Oh, that's not very good, Lloyd. Whereas I've run 100 tests today. That's better. I've run 1,000 tests today. The problem I have with the number of tests that have been run is people haven't a clue what a test is. Now, I could give our management a very large number. I've run 1 million tests today. Every keyboard depression on could be deemed to be a test. I pressed L, it's accepted. I pressed another L, it's accepted. I pressed an O, it's accepted. A Y, it's accepted. That makes up a number of tests. What about number of tests passed or failed? Okay, they don't know the reason behind the failure. It could be just because of a typo, whereas other failures could be a crash. Number of scripts that we've automated, and we'll come back to automation later. Number of defects raised and fixed, okay, and yet we don't know the background to what those defects are. So the larger the number, the better. That's what our managers say, but we are providing this information on a regular basis. So what's it used for? Is what's being analyzed? Is it really needed? Why do you need the number of tests I've run? Why don't you know about the quality of the system? Why don't you ask about the coverage of the system? So I think we should challenge our managers about the information they're wanting. Educate them regarding the test. Report about the quality or the cost savings or the cost of quality could be something that we might want to have as an alternative for our managers. So there's our next myth and illusion. Is the brim of the hat smaller than the height? Well, in actual fact, it looks smaller, but in actual fact, it is exactly the same height. And I didn't stretch that line, by the way, when you're thinking about it. I didn't stretch it. That's just PowerPoint. I'm going to come on now to something which I'm getting very, very concerned about in our society and our organizations. DevOps. Those of you who don't know what DevOps is, it's a new way of projects being developed. The concept I believe in, the concept is very good. The concept says that developers who develop software need to maintain that software when it goes into production. That's the concept, and I agree totally with that. Rather than separate maintenance teams, have the developers who develop it actually maintain it in production. But I'm going to give you a little bit of a history lesson. You see, back in the 70s, and that's where I started my career as a developer, we didn't have test groups. We had IT departments that were made up of a development manager. In fact, it wasn't a development manager in my organization. It was a chief programmer. He was in charge of every developer, and everything had to go through him. And we had a development team. But the thing is, back in those days, our systems were noddy. They were very simple. Going back to those days of creating programs, they were batch programs. They were dumb terminals. There wasn't any intelligence behind the fact. They were number crunching. They were producing reports or producing policy documents overnight. So the risk of failure was really, really small. And we fixed bugs in production. I remember getting called in, 2 o'clock in the morning to fix a production bug, and next morning we rerun the batch run again, and everything was fine. But the problem is that we, to date, our systems have grown in complexity far, far greater than we ever had in 70s and 80s. The risk of failures are much, much greater. We've now got software that are driving cars. I did some work in Budapest with a company there. This was about 7 years ago, and they showed me a prototype of a mobile app that was going to drive a car. Now that's in our systems now. You can get these cars that you can drive your car with the mobile app. Now, we're not talking about little batch processes that produces policy documents. We are very, very keen on getting the quality much, much greater because the risks are higher. So up to date, we started introducing testing, and that's where I began my career in testing. I moved from a development background into a testing background, and there was test managers and testing. But what's happening today, and I see it, and maybe it's a way that companies are bringing in DevOps, and it's wrong, but the number of organizations I've now seen where they've said, we actually don't need testing anymore. We are going back to the same route of having just development department with developers. And one company in particular in Norway that went down this route, they actually retrained the testers as developers, so they have many more developers. Now, let me talk about why this is a problem, okay? The problem here is that the DevOps community, or some of them, are saying we no longer need testing. This is fake news. Why? Well, firstly, our systems are much, much more complex and sophisticated than they ever were in the 70s and 80s. Technology has changed. Risks are much higher. We got systems that are automatically paying bills. We've got financial systems. We've got systems that are looking at software that's driving trains and aircraft automatically. So the other thing why I believe this is a wrong route is because testers and developers think differently. I've been a developer. I know what developers think like, and it's how can I get this to work? The tester's mindset is very different. The tester's mindset says, how can this system fail? The other thing is that we test, not only think differently, but we test differently. Evidence shows that developers, because they're looking at how can I get this to work, they're doing much more positive testing. Whereas when we're thinking as testers, how can this fail? We're doing much more negative testing and robustness testing and pumping sort of lots of negative inputs to see how it can cope. And the other thing, and I still do testing for organizations, and just before Christmas, I was doing some testing for an organization, and I thought that this phrase was long gone. And I was doing some testing for them, and something didn't work, and it was a serious bug. So I emailed the developer and said, I found this bug. I think we need to fix this very soon because I can't get on and do some other things. And he was quick to come back and said, Lloyd, I'm not sure what's happening. He said, but it works on my machine. Now, I've got a list of the top 10 responses by developers, and that's 20 years old. That's the #1 response. I thought that had gone. Now, the reason it was working on their machine is because I was working in a production environment, and they'd not moved certain modules into a production environment. And so that was the reason I found the defect and the developer didn't. But there is an argument that DevOps will work and you don't need testing if we're delivering systems that are of a low risk. So my website, for instance, very low risk. It was about 6 months ago that my website was down for a couple of days. I doubt very much if anyone that's listening actually noticed my website down. I did. I was probably the only one. So the risks are very, very low. Okay, let's have a look at the 6th myth. Anyone can test. I thought for 6 years in the organization that I was a test manager for to get the testers recognized for the work they did. It took me 6 years of battles with senior management to give them the same remuneration, the same company cars that developers had within that organization. And the problem was that when I joined, the management team said anyone can do this job. And I want to dispel this. You see, anyone can run tests, okay? It depends on the detail of the script. Anyone can have a system and do some testing, but that doesn't necessarily make them good testers, okay? Many organizations encourage other people to test, like customer service, developers, business. But that doesn't mean they're good testers, and neither does a certification make a good tester. Now, I'm very much into qualifications for testing. I teach the qualification schemes, so I'm an avid fan of that. But if you've got the foundation certificate in software testing, doesn't mean you're a good tester. It means you've been able to pass an exam, okay? Just like any exam. So I love cooking. That's one of my pastimes, and I wouldn't call myself a chef. I dabble with experimenting with food, but if I don't know how to do something, I will get a recipe, and the recipe is something I will then follow, you know, line by line to actually create that dish. So following a recipe, running someone else's test doesn't make them a tester. It doesn't make me a chef just by following someone else's recipe. So why don't we test the testers? Why don't we see how good the testers are, and you know, have sort of applications with bugs in it to see how good they are. Aptitude tests for testers when they come for job interviews. So why don't we see how good they are? You see, what we need are Jedi testers. Okay, I'm a big Star Wars fan, and Jedi, they don't use a rule book, they use the Force. Okay, so what we need to do as testers is allow ourselves to be curious. What happens if I do this? Be cautious. Okay, I've run these tests and I've not found anything. Is it my tests that are wrong? I think we should be critical and say, okay, this has worked, but how can it not work? We should understand and use design techniques as testers. Understand things like boundary value analysis, equivalence partitioning, pairwise testing, classification trees. And we should let ourselves be distracted. I always often say confusion, use it as a resource. If I'm confused as I test something, then customers are likely to be confused as well. And there's probably a defect there that we need to raise. Now, this is very controversial, and I'm actually in the process of writing an actual presentation on this very myth. Okay, and this is that test or development managers will always be needed. Okay, let's go back to the 70s and 80s, historical lesson. This is the situation. We may have had a development manager, we may have had a chief programmer, but we didn't have test managers, okay? In the 90s, we did have test managers, and that's the route I took. And then we had test departments because the systems were increasing. In the 2000s, early 2000s, we had what was called independent test teams, and I was an independent test manager reporting to the CEO of an organization. But the problem we have now, and this is my prediction for the 2020s, is that the IT department is made up of development and testing. And these people, and I put test managers and development managers in the same here, test managers and development managers, they have to change. And this is the reason. You see, traditional test managers fulfills two main roles. When I was a test manager for a software house, my job was two aspects. Firstly, I was organizing and leading test teams. I had a team of 13 people, and my role was to lead them, organize their work, give them tasks to do, and take their timesheets, put it in Gantt charts, etc. And I did that on a weekly basis. I also was planning, monitoring, controlling what got tested. So from this point of view, I was monitoring what was being tested. I was producing reports for my management team as well. So that was the past. But the problem is that those two roles, those roles of organizing and leading teams and planning and monitoring what gets tested, they're covered by other people nowadays in our projects. They're covered if you're working in agile teams. They're covered by Scrum Masters. Scrum Masters are there to facilitate things happening. They're there to take any problems that exist within the team and try to resolve them. The agile teams themselves are self-organizing. They know what needs to be done because it's on the task board. They do their own estimating. So this begs the question is, what role now is the test manager? How can we change? Well, hot off the press, this is what a presentation I'm putting together is all about. I don't think we should call them test managers anymore. I think we should call them test advisors. Now, it's unfortunate, certainly in the UK at the moment, about advisors to the government and what they are not and are doing. But in the main, I believe that the advisory role for things is a very, very strong. You know, we've got medical advisors to the government. We have advisors about certain aspects, you know, in this lockdown situation. And I think we should have test advisors where we're advising senior management about the quality of software and what the quality is and the cost of quality and why it's very dangerous to go for a bronze service rather than a platinum service. Advising testers about ways and types of tests to do, mentoring them, coaching them. My father, when he was alive, was a carpenter, and the industry of construction, we really do need to learn from them because they have mentoring, they have apprenticeships and coaching people before they're let loose on site, you know, as an electrician. And I think we should coach testers and developers about this, advise senior management about the information that is needed or what they should be asking for, and also advising teams about how to measure their effectiveness of testing. Just a quickie on effectiveness. If my test team have found 30 defects and it goes live and the customers find 300, my team have not been very effective. But if my team have found 300 defects and the customers find 30 defects, then my team have been very effective. So that's another way we could have test advisors. So we're coming towards the end of these. There's just 3 more myths and illusions. So here's another myth. Software quality is achieved through testing. Here's the fact. Testing can find bugs. Absolutely. I use the word can, not will. Testing, removing bugs improves the software quality. That's absolutely fact. So when we remove those defects from our software, the quality of the software improves. So therefore, what we sometimes use, and I've seen this in organizations, sometimes they say, well, if testing can find bugs and removing those bugs improves software quality, therefore testing improves software quality. Not true. Here's what I mean. Our system has 9 bugs. Testing comes along and we find 5 of those bugs with our tests. Net result, quality is still the same. There's 9 bugs, we've just found 5 of them. But developers come along and they fix those 5 bugs. Net result is quality is improved. So it's testing together with development improves the software quality. Testing on its own can never, ever improve the software quality. We are working in conjunction with the developers on this. One of the things we do in software testing is to assess the quality of the software. It's a bit like dipping our elbow into the temperature of a water to see how the temperature, what that temperature is. And basically, we dip our elbow in to the quality of the software. So here you go. So we've got a measurement on our software quality. It varies from low to high quality. So if we find loads of bugs in our testing, that's a good thing. So we're there. The software is pretty low. We find a bug here, we found another bug, and it's pretty poor quality. But if we don't find many defects, okay, so you know we're running tests and we're not finding anything, we could jump to the conclusion that the software quality is very high. So we think we're actually there, but in actual fact, we could be there, or we could be here. Now, what's missing? Well, the dimension is how good your tests are. So let me focus on these 4 quadrants for you. You see, let me have a look at this first quadrant in the top left-hand side. The software quality is low, the test quality is high, we find loads of bugs. That's a good place to be as a software tester. Management don't like it, but they have to live with that, okay? It's our job to find those bugs and get those bugs removed along with developers. Let's have a look at the next quadrant. This is where the software quality is high, the test quality is high, and we don't find many bugs. That's another good place to be as a tester, because that's like acceptance testing. We're getting lots of confidence. But let's have a look at the bottom left-hand quadrant. Software quality is low, the test quality is low, we don't find many bugs, your customers will. That's not a good place to be as a tester. But my favorite quadrant is the bottom right-hand quadrant. You see, the software quality is good, very high, the test quality is bad, not very good, we don't find many bugs, that's called lucky, and that's not a good place to be as a software tester. So to have justified confidence in the software quality, whether that's low or high, we must have justified confidence in the quality of our tests. Our quality of our tests must be excellent. Here's another illusion. Which circle in the middle, on the left and the right, is bigger? Well, in actual fact, they're both the same. So we come to our penultimate myth. And I'm not a fan of these at all. So for those that don't know what I'm talking about on detailed scripts is a prescriptive set of instructions on running your tests. So step 1, switch machine on. Step 2, wait for Windows. Step 3, click icon. Step 4, wait. That's a prescriptive script. Now, the problem I have with this is like a map. And the map tells us how we can get through this maze. Step 1, go down 4 steps, then turn left, and then go 6 steps, then go straight on, then take a left, then go, etc. So our script actually goes through, and we may be lucky to find 5 bugs. But the problem is there are other bugs in our system. Now we've raised those 5 bugs, and those 5 bugs reports get fixed, and bing, they're gone. So we run our script again, and lo and behold, it works. And we think things are great, and they're not. And this is why I am not a big fan of detailed scripts. There are 3 reasons we have detailed scripts. Firstly, if you've got inexperienced testers. Let's go back to the analogy of a novice cook. I need a recipe. You know, if you want me to make a Thai green curry, I wouldn't have a clue on how to start. I would need a recipe. So inexperienced testers need instructions, okay? But I think there's still better ways of doing that. I think we can get alongside them, we can mentor them. It provides the basis for test automation. Test automation is, and certainly execution tools, will allow us to execute our tests unattended. But you have to tell the automation tool exactly what to do. You have to give it the step-by-step set of instructions. So that's a good reason to have detailed scripts. And also, a very loose reason is to provide an audit trail. Some systems, some organizations need to have an audit trail for legality. Now, there are tools out there that will do this automatically for you. So just having a set of scripts and say, yes, I've done it, you might be able to use something like Snagit or Blueberry or Gene to actually create the audit trail for you. So risks here, I believe detailed scripts are boring to write, they're boring to run. I think more time sometimes is spent on the script itself rather than the execution. I had one organization told me that a certain script took 3 hours to write for 15 minutes of test execution. That is the wrong way around. We should have 15 minutes of writing tests for 3 hours of test execution. Test execution finds the bugs. Our scripts, writing them, does not. And also, if any of you have been involved in maintaining these scripts, absolute nightmare. And they provide a false confidence with the quality of the system. So if I go back to this, running that script again, and I say, actually, it's all worked, it must be good, it gives me a little bit of false confidence because there are other bugs in the system. Okay. And also, your best tester will probably leave. It's a bit like this. If I ask Gordon Ramsay, a well-known chef, and said, Gordon, would you be able to cook me a Thai green curry for me? Gordon would say, yes, I'll cook a Thai green curry for you, no problem. If I then turn around and said, but could you use Jamie Oliver's recipe to follow exactly, he'll probably use the F word a lot, but our testers will probably leave if they have to do that. I've got empirical evidence that shows that exploratory testing will find 13 times more defects than running scripted testing. So we've got our last myth and illusion. And this is something else that's coming in organizations, that we've got to automate everything for better efficiency and effectiveness. The fact is that if our automation effort is less than our manual effort, then we've got a cost saving. But if it's not, if it's the other way around, then if our automation effort is much more than our manual effort, then it's a cost that we incur. So the myth here is that automation is not effective as human beings at finding bugs. So how good is our regression packs? We automate the easy tests, we automate the happy path, we add to the regression test, but we never ever know how good those regression tests are. So here's an idea. It's called fault seeding. So what you do is you run your regression tests, you then seed your system with 100 bugs. You can either use a tool to do that or ask the developers to actually put the bugs in. Then run your regression tests again to see how many of those 100 bugs that have been seeded you actually find. And by the way, if you do this, make sure you know where those 100 bugs are and they can take them out. Otherwise, you've got an extra 100 bugs that are going to go out to the customers. So tool support rather than automation, it's there to help us. So here's some disturbing case studies. Let me talk about company number one, because if you want to read the article, I think it's still available, by a guy called James Whitaker. He wrote an article on why Windows Vista sucks, typical American phraseology there. But he did. He was brought into Microsoft to as a consultant to see why Windows Vista was received so badly, and his findings shocked the management team because he said, "You've spent too much time automating." And they said to him, "James, would you like a job?" And he said, "I will, as long as I can head up an exploratory testing guerrilla warfare team." And that's what he's doing to this day. He's still at Microsoft heading up those teams. Outsourced team and automated 10,000 test cases. And when they looked at what these test cases were doing, they were doing the same thing. So they were just achieving faster rubbish. So I've come to the end of my top 10 myths and illusions. I hope we've got just a little bit of time to show you this little video clip, and then I'll hand back to Debbie. But some of them, these myths, like anything, are passed down through generations. You know, we've always given management, the number of tests we're running. And I think sometimes we need to challenge that. Some myths are based on partial truth, DevOps, where, we don't need testers. That's a partial truth when the risks are really, really, really low. And also, it's easier to swim with the current than against it. And so therefore, what, at the source sometimes seems believable. Your grandmother told you that eating crusts of bread will make your hair curl. It's your grandmother, so she must be right. So I think we need to challenge. We need to train the eye of our organizations, early warning signs and symptoms of what is a myth or an illusion, and actually challenge some of these things as well. So I hope this has been helpful. I hope that within your own organizations, you maybe have seen some of these things take place. And I hope that I've given some insight as to what you might be able to do about this. So Debbie, have we got time? Just it's just a 3-minute video to play this, or?
Yeah, we're good. We're good, Lloyd.
Okay, right. So some basic Penn and Teller here. So I'm just trying to get my mouse. Seems to.
We did a series of television shows. We saw magic all over the world. Went to Egypt, China, and India, and every magician we saw had a version of the cups and balls. And the trick all around the world didn't change very much, but the props did. And in China, they had these metal cups handed down generation. In India, they had these hand-carved wooden cups, but we used plastic cups because we were representing the United States of America. So these are the plastic we use. We also use for balls, we use tinfoil balls. So we have the totally American, totally disposable cups and balls. Goes like this. This is what it's done everywhere. Take the ball, we place it in our hand, we vanish it, and it appears underneath the cup. And that's what it's done all around the world. We just take the ball, we place it in our hand, we vanish it, and it appears underneath the cup. Here's a little variation Teller came up with, where he takes the ball, places it in his hand, then shows you underneath the cup, yet it still appears underneath the cup. Now, if I do the center ball, place it visibly against the center cup, then do side balls, put them anywhere we want, they still reappear in the center cup. You've already seen a little juggling here, but there's a little more of it. Then a giant ball in the center cup, one more giant ball on either side, and of course, for the finish, it's a baseball. As embarrassing as you can get. It's not done yet.
That was good enough for me.
That's the standard version of the cups and balls. After we did that for a while, we wanted to kind of zoom in and do a Penn and Teller version of the cups and balls, which involves breaking a few rules of magic. Now, the first rule of magic is you never do the same trick twice. You had the sense of that right away. You're going to get us out of there. Don't do it again. We're going to do it again. Second rule is you never tell an audience how the trick is being done. So I'm going to tell you exactly how the trick is being done. The third rule of magic is you never let the audience see your secret preparation. They must not know what is hidden in which pocket. And the fourth rule of magic is unwritten, but I think any magician in the world would agree with us in a second that you never ever do the cups and balls with clear plastic. This is the Penn and Teller version of the cups and balls. We take the first ball, pretend to place it in our hand, having already snuck it beneath the first cup. Get the second ball, simultaneously secreted beneath the cup, pretend to place it in our hand, and show it. Take the third and final ball, pretend to place it in our hand, pretend to show it the cup, place it in the cup, and then secretly secrete it and reveal it. Now we're all set for the second half. The cup's all loaded, 3 balls on top. The center ball, place center cup. Each of the side balls ready, put them away. We don't need them more. We have 3 duplicates in each center cup. These 3 balls come over here. This is not juggling. This is called misdirection. For I look over here, tells us the final ball under, 1 more on either side. And of course, for the finish, it's an American baseball.
Okay. Thanks very much indeed. I'm going to pass over to Debbie now, so change presenter.
Thank you so much, Lloyd. That was really entertaining and some really great information there. Just going to follow up on a few questions here. Actually comment. So Vanessa, talking about, you're talking about the myth of estimation. And Vanessa says, oh, sorry to disagree, but some managers do want estimates and are okay with approximate figures to base their decisions on. So I think she's challenging, saying that perhaps your statement is a myth, Lloyd?
Well, yeah, I mean, there are some organizations where the management realize that an estimate is just an estimate. But I've been in very few organizations that allow people to re-estimate testing. And my point is that, yes, they're okay with a sort of a vague idea of what it will be, but when we then go back and say, well, actually, we got that wrong, it's actually, twice that, they're sort of less inclined to give us that extra time. And that's just my experience. And I just think if there are managers, and maybe managers have come through the testing route and they know about testing anyway, and therefore they're more akin to receiving just sort of the approximations, which I think is brilliant. And applaud people and companies that allow that. So yeah.
A comment, I guess, common question here from Danielle. Anyone can test. We have full stack developers. Why couldn't we add one more skill to full stack dev list, full stack developer tester?
Well, yes. I mean, the key here is what I was saying about the mindset. the mindset of developers and testers are very, very different. And I've been a developer. I know how to develop. I didn't like it, but I do like testing. And yes, we can encourage developers to test. We can provide them with courses to go on and add another string to their bow. But when they're developing software, they're still looking at how to get that software to work, rather than how can this system be broken. And I think that's the main issue. And going back to just an example, the Boeing 737 MAX, that software problem, Boeing, because they wanted to get that aircraft up in the sky, decided to downgrade that software to a minor. Now, we might not think that that's important, but if it's downgraded to a minor, the FAA do not have to get involved. And so it bypassed the FAA for independent testing. Now, I'm not saying the FAA would have found that issue, but it's interesting that because of that, the developer were developing the system and testing the system, and it just slipped through the net. So yes, we can educate developers to do it, but we've still got to think about the mindset behind it, and also the environments they're working in. You know, are they working? Do they actually transport it to a more production-like or a customer-facing environment? So that's something to think about.
Thank you, Lloyd. We're actually a little bit over time, but I just want to go ahead and cover these questions. How would we estimate the quality of a system when we find difficult to estimate the testing of the system?
Yeah, and a lot of people are they find it hard to do this because, you know, it's hard to estimate testing at the good point. But if we're trying to estimate the quality, how can that be done? And there are a number of things. Just guess. I mean, the last project you were working on, how many defects did you find? Okay, this project you're working on now, is it a bigger or smaller project? And use that as a basis. We could use, as I said, the story point system where, you know, if we're in Agile and we're saying, well, this is one story point user story, then I'm going to find maybe 3 defects, and it's a 1-to-3 ratio. So there are ways we can do it statistically, but also just guess. And I think people are more afraid of guessing just by being challenged. And it's not necessarily the number, but it's actually just monitoring the quality afterwards.
Thank you. Yeah. My manager has always asked me for information relating to the project. How do I challenge that when, I'll say he, she is my manager?
Yeah, it's difficult, especially if you know, they are our managers, and you know, to go out and actually sit and challenge them face to face. And I think sometimes we need to do it in a very courteous way, not bolshy. But I think we can ask them, you know, if they're saying, so how many tests have you run today? Just ask the question, so how are you using this information? And you know, get information from them, and maybe offer. I remember my manager turning around and saying to me, Lloyd, he said, I don't want problems, I want solutions. And I think going back to them and saying, well, maybe the quality is a much better measure, or maybe the coverage is a much better measure. Have you thought about that? And I think we could do that in a courteous way, but we have every right to challenge, because otherwise it's, you know, it's this thing that's handed down and we keep on doing it, but we really don't know why.
A final question for you, Lloyd, because I think this is fabulous. How do we actually become Jedi testers?
Well, a very good question. You've got to use the Force. Definitely got to use the Force. No, I think when it comes to Jedi testers, I think the key here is you've got to practice, practice, practice. And I'm constantly trying to increase my testing skills by testing applications for people, organizations. I mean, just before lockdown, I was over in Norway helping an organization, a major bank there, testing their system. And I think we've got to refine our skills. We've got to look at, you know, what makes a good test? Why did that test find a defect? Use techniques, understand techniques. Techniques are our toolbox as testers. So understand and grapple with techniques. Boundary value analysis, for instance. Yeah, we measure boundary value analysis, but what about this? What about internal boundaries? What about the 2 to the power of, you know, 2, 4, 6, 2, 4, 8, 16? They're all internal boundaries of the system. and therefore that's a good number to actually to put in. So it's just practice really to become that Jedi tester.
Lloyd, thank you so much. I just want to say a big thank you to everybody who has joined us too. Just one comment here, Alexei, yes, the recording will be uploaded to the iSQI YouTube channel. There's a lot of recordings on there which people I hope will find useful. So I'm going to say thank you again so much, and may the force be with you all, and wish you all a good evening. Thank you for everyone attending, and to Lloyd. Take care. Bye-bye.
Bye.